Hello, calculus fans. Let's convert 1 root 3 negative 2 root 3 from rectangular to spherical coordinates. So we're starting with x equals 1, y equals root 3, z equals negative 2 root 3. We need to find rho, theta, and phi. Okay, let's start with rho. That's the easiest one. So we use the distance formula. We just say rho squared is equal to x squared plus y squared plus z squared. And then plug in those values that we have, x, y, and z. We end up getting rho squared equals 16. And so that tells us rho is equal to 4. All right, next thing to do is to find theta and phi. Now note that the projection of this point into the xy plane is in the first quadrant because the x and y that we were given were positive. So we know that theta is going to be between 0 and pi over 2. Just keep that in mind. Now we know that rho is equal to 4 and z is equal to rho cosine phi, and that's equal to negative 2 root 3. Well, we know rho, we know z, so let's solve now for cosine phi. We'll get 4 cosine phi equals negative 2 root 3. So cosine phi is equal to negative root 3 over 2. So that tells us that phi is equal to 5 pi over 6. Now the last thing we need to do is we'll take rho equals 4, and now x equals rho sine phi cosine theta, and we know that's equal to 1, right? We're given that x is equal to 1. And we've now computed that phi is 5 pi over 6, so let's plug everything in. And that enables us to solve for cosine theta. Cosine theta will be equal to 1/2, and that tells us that theta is equal to pi over 3. Remember that we had some information that theta was a first quadrant angle. It is possible that cosine theta can be equal to 1/2, but be in a different quadrant. Remember that cosine is also positive in the fourth quadrant, so it's possible if we had some other information that we could have gotten a fourth quadrant angle. All right, let's put all this together. We get that the spherical coordinates of the point are 4, pi over 3, 5 pi over 6. Remember that's rho, theta, phi. Okay, that's all for now.